So now it is very important to learn the Laplace transform of some special function. Laplace transform of some special functions. So in that first function we are taking that first example, that is finding the Laplace transform of error function of root t. Basically, first of all, you must know what is an error function definition. So this is the definition and notation for error function. So the definition and notation for error function is this. So ERF we are supposed to write, and whatever the variable, that variable will come inside the bracket, and the formula for error function is this 2 upon root pi integration 0 and whatever there after error function, that variable will come as an upper limit, and then you have e raised to minus x square dx. This is the definition of error function. Please look at the definition carefully. This is the notation error function, and whatever the variable, that variable will be, this is the variable. In the definition of error function, you have 2 upon root pi, this is 2 upon root pi, and then in the integral you have lower limit as 0 and upper limit as this, whatever variable at here, that will be an upper limit, and inside the integral we have the function is as it is, that is e raised to x square dx. So now since we want to find the Laplace transform of error function, so our aim in this particular lecture is to find Laplace transform of error function of root t. So how to find this? So for that you must know what is this error function. So first what we'll do, we'll just consider this error function separately, error function of this root t, and we write down its definition. So the definition of error function root t is 2 upon root pi integration 0 and inside the bracket e raised to minus x square dx, and just whatever after error function variable, that variable will be in the upper limit. So this is what is the definition. Now since we want to find the Laplace, so to find the Laplace of error function, at now I have not defined any formula for finding the Laplace transform of integration, and that too of this particular type of integration. We have not seen any formula for finding the Laplace transform of integration. So how to solve? How to find the Laplace transform then? So for finding the Laplace transform, we have to, for finding Laplace transform, we have to simplify this. We have to simplify right hand side integration. So how you are going to solve this integration? So just we will consider the right hand side integral. So right hand side integral is integration 0 to root t e raised to minus x square dx. Now again there is a problem. You see that inside the integral we have e raised to minus x square. So how to solve this integral? Again it is not solvable using gamma function, because gamma function limit is 0 to infinity. So it is not solvable gamma function. So here we are using a technique of expansion of function. So by using expansion of function, we have the expansion formula of e raised to variable. The formula is 1 plus whatever that variable divided by 1 factorial plus whatever the variable its square divided by 2 factorial plus whatever that variable its cube divided by 3 factorial. So this is the formula. So I can use this formula and we can simplify. So instead of e raised to minus x square, we can write as 1 plus this minus x square, because in the bracket we have, see in the bracket we have box, we have minus x square. So whatever, wherever the box is there, the minus x square will take the place of box. Then again here minus x square divided by 2 factorial, minus x square of square divided by 2 factorial. The next term will be minus x square of cube divided by 3 factorial, and so on. So these will be terms, and now we can simplify this. So its simplification is simply 1, and this is will be minus x square and then minus x square of square. So it has to be an x raised to 4 divided by 2 factorial. So 2 factorial, we know that 2, or you can write down 2 factorial as it is, and this has to be minus x raised to 6, because you have the negative power, minus 1 odd power divided by 3 factorial, and so on. So there will be many terms, but restriction of the space and all that, we are writing only this much. Now since your integral, so we have to solve this integral. So your integral I will look like an integration of 0 to root t, and instead of this e raised to minus x square, instead of the e raised to minus x square, we can write this e raised to minus x square expansion. So we will write down that expansion. So the expansion is 1 minus x square plus x raised to 4 divided by 2 factorial minus x raised to 6 divided by 3 factorial, and plus so on, as many terms as possible you can write, and then dx. Now next is you have to solve this integration. Solving this integration, so writing the steps one by one, it will be very difficult. We will directly write down the integration. One integration with respect to x is x square integration is x cube by 3, x raised to 4 integration is x raised to 5 divided by 2 factorial into 5, and then if you are happy, you can write, or you can skip writing remaining terms, and then the limit. So the lower limit is 0 and the upper limit is root t. Root t is nothing but t raised to half, we can write that. So that's why I have wrote over here t raised to half, and now we can substitute the limit. Instead of x, the upper limit is t raised to half. So here it will be t raised to half, here it will be t raised to half raised to 3. So using laws of indices, a raised to m raised to n will give you a raised to m into n. Using that property, we will have t raised to 3 by 2 upon 3 at here. At here it will be t raised to 5 by 2 upon 2 factorial into 5, and so many terms, and then minus times 0. So since 0 is there, so at everywhere 0 will put, so no need to write briefly. So we have able to find out the value of this integration I. Now we will put into our Laplace transform. So your required Laplace transform will look like, so Laplace transform of error function of root t. So it was having 2 upon root pi and then integration, but instead of integration we have, so just now, so now since we have to find the Laplace transform of error function, so we are able to find out the value of this error function of root t. So error function of root t is nothing but from 2 upon root pi and this whole bracket, that is t raised to half minus t raised to 3 by 2 upon 3 plus t raised to 5 by 2 upon 5 into 2 factorial and many terms. So that's what. So now you can find the Laplace of this error function of root t. Error function of root t will be equal to, simply in the right hand side also Laplace, and then inside that 2 upon root pi, and then again in the bracket we have this whole function t raised to half minus t raised to 3 by 2 upon 3 plus t raised to 5 by 2 upon 2 factorial into 5 minus many terms. And so you know that the linearity property of Laplace transform, this 2 upon root pi is constant, so we can write down this 2 upon root pi as it is, and so this L will go and apply to this bracket. So L will be t raised to half minus t raised to 3 by 2 upon 3 plus t raised to 5 by 2 upon 2 factorial into 5 minus, so in that way. So now 2 upon root 5 will be as it is, so 2 upon root 5 I will write as it is. Now Laplace of each of the functions from the bracket, so we can find out that Laplace, so the Laplace will be simply t raised to half Laplace. So what is the formula we are going to use? T raised to n wala formula. What is that formula? Gamma of n plus 1 upon s raised to n plus 1. So here it will be gamma of half plus 1, that is 3 by 2. So upon s raised to 3 by 2. So similarly upon here 1 upon 3 is constant, t raised to, that will be gamma of 5 by 2, gamma of 5 by 2 upon s raised to 5 by 2, then plus this will be gamma of 7 by 2, 5 by 2 plus 2, 7 by 2 upon 2 factorial into 5 s raised to 7 by 2. So in that way we can write down the terms. So this is what happened, 2 upon root pi, and we can simplify all these steps. So after simplifying, you see that this gamma 3 by 2 will be as it is. So gamma 3 by 2 upon s raised to 3 by 2 plus here you can write down 1 by 3. Gamma 5 by 2 is nothing but, we have the property of gamma function, gamma n is equal to n minus 1 into gamma n minus 1. So 5 by 2 minus 1 is 3 by 2, 3 by 2, gamma 3 by 2 I can write down, and so does in the denominator 3 upon, this 3 is already there, s raised to 3 by 2, s raised to 5 by 2 will be there, plus gamma 7 by 2 we can write down as a 5 by 2, 3 by 2, and then gamma 3 by 2 divided by, this is 2 factorial into 5 s raised to 7 by 2, and then minus will be there, minus times and the bracket, and now whatever common you can take. So gamma 3 by 2 is common, so we are taking out, and then again from the denominator s raised to 3 by 2 is common, so we are taking out, since it is there. See, gamma 3 by 2 and s raised to 3 by 2 is there everywhere, gamma 3 by 2 s raised to 3 by 2. So here it will be only 1, and now this 3 and 3 get cancelled, so we have 1 upon 2, and s raised to 3 by 2 is going, so we are having at here is s raised to 3 by 2 is going, so what remain at here? Just 1 by s remain, because 5 by 2 minus 3 by 2, that is 2 by 2, so 1 by s, plus in the next term, sorry, this will be the minus term, this is the minus term, this is also minus term. So now again simplifying at here, so this 3 by 2 and from here it will go, so what remains, 5 and 5 got cancelled, so we have 3 upon, will remain at here 3 upon, so 3 upon 8, this 2 into 2 4, 4 into 2 8, 8, and then 5 and 5 get cancelled, 3 in the numerator, and we are having at here 7 by 2 minus 1. So 7 by 2 minus 3 by 2, 7 minus 3 4, 4 means s square will remain at here, so minus in this way. So then we can again simplify it here, so this is 2 upon root pi as it is, and gamma root 3 by 2 is nothing but 1 by 2 into gamma half, and so does this is s raised to 3 by 2, and in the bracket this is nothing but 1 minus 1 upon 2s, 1 by 2 times 1 by s plus 1 by 2 into 3 by 4 times s square, and then minus these many terms. So, this 2 and 2 get cancelled, root pi and gamma half is nothing but gamma half value is also root pi. So, here we are having only 1 upon s raised to 3 by 2, and about this is nothing but 1 plus 1 by s raised to minus half. This is the formula, expansion formula. You can see this expansion formula of 1 up plus box raised to minus half. The formula is this: 1 minus times 1 by 2 times box plus 3 by 8 times box square, and so on. It is a formula. So, that is what happening at here. And now we can simplify this steps. So, this is 1 upon s raised to 3 by 2 is as it is, and we can simplify this by making common denominator. So, it is s plus 1 upon s raised to minus half. So, this is 1 upon s raised to 3 by 2. So, this becomes, now since minus power, so a raised to minus 1 is nothing but 1 by a. So, I am just flipping this. So, it will become s upon s plus 1 raised to half. So, so togetherly this is nothing but 1 upon s raised to 3 by 2 s raised to half upon under root of s plus 1. So, s raised to half and this will get cancelled. So, we have 1 upon s at here and under root of s plus 1. So, this is the Laplace transform. So, we have got the Laplace transform. So, Laplace transform of error function of root t we have got, and it is nothing but 1 upon s under root of s plus 1. And again there is a relation there is one more function, error function c of box, and there is a relation between these two error functions. So, error function of box plus error function c of box is always 1. So, for that reason, so you can find the Laplace transform of error function of c of box, which will be simply Laplace transform of 1 minus error function of box. So, which is nothing but Laplace transform of 1 minus Laplace transform of error function of box. And now you can find the Laplace transform of error function c of box.